everyone, welcome to my YouTube channel. I am Manas ISR studying in Sri Venkateshwara College of Engineering from 6M ISC. The subject is file structures. Today I am going to discussing about single level indexing of record by key. Single level indexing of record by key. Single level index. A single level index is an auxiliary file that makes it more efficient to search for a record in the data file. The index is usually specified on one field of the data file. One form of an index is a file of entries. Field value pointed to record, which is ordered by field value. The index is called an access path on the field. The index file usually occupies considerably less disk blocks than the data file because its entries are much smaller. The binary search on the index yields a pointer to the file record. Types of single level indexes. First one is primary index, second one is clustering index, and third one is secondary index. Now let us know about primary index. A primary index is an ordered file whose entries are of fixed length with two fields. First one is value of primary key, second one is address of data block. The data file is ordered on the primary key field and requires primary key for each record to be unique or distinct. It includes one index entry for each block the data file. The index entry has the key field value for the first record in the block, which is called the date block anchor. A similar scheme can be used for the last record of a file. Now let us know about performance. Generally, secondary indexes leads to more storage space and longer search time than for primary indexes. However, for an arbitrary record, the improvement is greater as otherwise we would have to do linear search. Example performance guide. Now suppose ordering key v equal to 9 bytes long and block pointer p equal to 6 bytes long. Size of each index entry ri equal to 9 plus 6 equal to 15 bytes. Blocking factor b of ri equal to 1024 divided by 15 equal to 68 entries per block. Total number of entries ri equal to total number of blocks in data file equal to 3000. Number of blocks needed for index is bi equal to ri divided by b of ri equal to 3000 by 68, total 45 blocks. A binary search of index file would need log2 bi equal to log2 b 45 equal to 6 block accesses plus 1 block accesses into the data file itself using the pointer. Therefore 7 blocks accesses needed. Now let us know about clustering index. Clustering index is an ordered file whose entries are of fixed length with two fields. First one is value of clustering key, second one is address of data block. The data file is ordered on the clustering field, but the clustering key does not have distinct value for each record. Index includes one index entry for each distinct value of the clustering field. The index entry points to the first data block that contains record with the data field value. Insertion or deletion still problematic due to ordering of gain data file. To solve it is common to reserve a block or contiguous blocks. This block is example for clustering index. Now let us know about secondary index. A secondary index is an ordered file whose entries are of fixed length with two fields. First one is value of key, second one is address data block or record pointer. The secondary key is some non-ordering field of data file, frequently used to facilitate query processing. For example, say we know that queries related to generate are frequent. Select star from movie where generate equal to comedy. We can ask the DBMS to create a secondary index on generated by issuing the following SQL command. Create index, generate index on movie generate. Secondary index of block pointers and secondary key type. Secondary key index where unordering field is not a key. Option 1 includes several index entries with the same first value, one for each record. This is a dense index. Option 2 have variable length index entries with the repeating field for the pointer. For example, key ki, pi, 1, pi, k. For these two options, the binary search algorithm needs modification. Now let us see option 3. Keep one index entry per value of the fixed length with a pointer to a block of pointers, that is add a level of indirection. If pointers cannot fit in the allocated space for a block of pointers, use an overflow or linked list approach to cope. Secondary index of record pointers and non-key type using option 3. Consider earlier example. Recap. R equal to 3000 fixed length record of block size B equal to 1024 bytes. File as 3000 blocks as we already calculated. Linear search would require B by 2 equal to 3000 by 2 equal to 1500 block accesses. Suppose a secondary index 1 on a field of V equal to 9 bytes. Thus Ri equal to 9 plus 6, 15 bytes. B of Ri equal to B by Ri equal to 1024 divided by 15 equal to 68 entries per block. Number of index entries Ri equal to number of records equal to 30,000. Number of blocks need is Bi equal to Ri divided by B of Ri equal to 30,000 divided by 68 equal to 442 blocks. A binary search of index file would need log to Bi equal to log to 442 equal to total 9 block accesses plus 1 block accesses into the data file itself using the pointer. Therefore 10 block accesses as opposed to 1500 block accesses. Example, retrieval in threaded files. To find all green Ford cars, we have three options. First one is traverse the list of Fords, checking each to see if the green. Second one, traverse the list of green cars, checking each to see if it is a Ford. We would prefer to traverse a short list. Index entries could include a thread length. Traverse both threads simultaneously requires that record are threaded in pointer order. Review basic operations involving indexes. Retrieve a record based on the key. Create the original empty index and data files. Both the index file and the data file are created empty. Add record to the data file and index. Adding the new record to the data file requires that we also add a record to the index file. Adding the data file is easy. Just add at the end or at the an existing gap between the records. Adding to the index is not easy because entries of the index file have to be sorted. This means that we have to shift all the index records after the one we are inserting. Essentially, we have the same problem as inserting records into the normal sorted files. Review. Indexes allows accesses using different keys without duplicating all the records. Avoiding duplication saves storage. Avoiding duplication makes modifying the data easier. We don't have lots of different copies to keep up to date. Indexes allow a lot of flexibility in the layout of the data file. We don't need fixed length records. We can store records in any order. Yet another way of organizing secondary indexes, multi-lists, like threaded files, but index contains a pointer to every kth record with the particular attribute value. Speeds of merge operations can skip over the rest of sublist if the next pointer in the index is still smaller than the current pointer in the other thread. Cellular multilist, like an inverted file but only lists the secondary storage blocks which contains records with the attribute value. Compromise between the threads and inverted files. Another way of organizing secondary index inverted file. The inverted file contains one index entry for each value of the attribute in question. The entry contains a list of pointers to every record with the last attribute value. For example, secondary key of car manufacturer. Audi 11, BMW 3, 9, 16, 17, Ford 1, 4, 5, 7, 10, 14, 18, 19, 20, Honda 15, VW 2, 6, 8, 12, 13. Why called an inverted file? Consider the main file has a function which maps addresses to file address, attribute 1 value, attribute 2 value. Inverted files are functionally the inverse of the main file. Invert file, attribute value, address and so on. A number of attributes can be inverted. Degree of inversion of the file, the percentage of attributes indexed in this way. 100% inversion is when every attribute is indexed. Queries on multiple keys need to refer to the main file if all the keys in the query are indexed. Consider a query for the record number of green Fords if both color and manufacturer are indexed. Consider earlier example. Recap. R equal to 30,000 fixed length. Record of block size 8. B equal to 1024 bytes. File as 3000 blocks as we already calculated. Linear search would require B by 2, 3000 by 2 equal to 1500 block accesses. Suppose a secondary index on a field of V equal to 9 bytes, thus Ri equal to 9 plus 6, 15 bytes. B of Ri, B divided by Rw, Ri equal to 1024 by 15, 68 entries per block. Number of index entries Ri equal to number of records equal to 30,000. Number of blocks needed is Bi equal to Ri divided by B of Ri equal to 30,000 divided by 68 equal to 442 blocks. A binary search of index file would need log2 Bi equal to log2 442 blocks equal to 9 block accesses plus 1 block accesses into the data file itself using the pointer. Therefore 10 block accesses as opposed to 2500 block accesses. Thank you.